Hello guys, hope you all are feeling well. Today I'm here with a very beautiful equation that is used to manipulate the received power density on the receiving side of the antenna. We call it Friis transmission equation because it's obvious for the electromagnetic waves. When we are talking about the electromagnetic waves are the disturbances in 3D space, right? And these disturbances are getting weaker and weaker if you increase the distance from your transmitter to the point where you are observing these electromagnetic waves with inverse square law. So it's obvious the power that you are delivering to your transmitter will not equal to the power that is on the receiving side, right? So we need a mechanism to calculate the receiving side power density. For that mechanism, this beautiful equation is here. We call it Friis transmission equation. Here you see this equal sign. This equal sign is basically telling us that the PR, transmit power, received power, max means the maximum received power, is equal to the PT, that is the transmit power, multiply with the GT, that is the gain of the transmitter, into lambda divided by 4 pi r whole square. This whole thing is the free space path gain basically, and this GR is the receiver's gain. So the scenario is a bit simple. This is the transmitter antenna, and this transmitter antenna is connected with your transmitter here. This is the receiving antenna, and this receiving antenna is connected with your receiving unit here. This GT is the gain of this transmitter antenna, and GR is the receiving antenna's gain. And the distance between this transmitter antenna and the receiving antenna is R, represented with R. Its R is here, right? So now we run up a scenario, a numerical problem in which we are trying to manipulate how much received power we are receiving if we are supplying 400 watt power to the transmitter. Now this is the transmitter antenna, this is the receiving antenna. The scenario is here. The distance between this transmitter and the receiving antenna, it's 45 kilometers, right? And PT, the transmit power, equals to 400 watt, and the gain of the transmitter is 60 dB. Likewise, the gain of your receiver is 30 dB in this scenario, right? And what we require is the PR that is required basically. So what we need is this Friis transmission equation to calculate everything. Now what is we just start on this scenario. We will put the values in the equation. First of all, we write the equation here. PR, received power max, is equal to PT GT into your lambda divided by 4 pi r whole square into GR, right? So this is Friis transmission equation. Now we are substituting the values here. PR max is equal to PT is 400 watt, you put here. GT is 60 dB. Then comes this lambda divided by 4 pi, and this R will come here. In our case, this R is 45 kilometers, so it's 45000 meters if you convert it, right? Kilometers to meters, right? And this is whole square, and GR is 30 dB. Now simplify it a bit more. What we get is this thing, lambda divided by 4 into 3.14 into 45000, right? This whole square will come here, right? Now lambda is 6 nanometer in our case, so 6 nanometer is equal to 6 multiplied by 10 raised to the power minus 9 meters. So substitute the value here is 400 multiplied by 60 multiplied by this into it's 6 multiplied by 10 raised to the power minus 19. I'm just substituting the value of lambda here, divided by this 4 into 3.14 into 45000, right? and the square here. Simplify it a bit more, and what we get is multiply by 60, multiply by 30 into you can get this, you solve this thing, and out of it what you get is 1.12693 multiply by 10 raised to the power minus 28. So just do the little math here, okay. So 24 240, and it will become 6720000 multiplied by 1.12693 multiplied by 10 raised to the power minus 28. So just solve it a bit more, and what we get here, what we get is it's 8.1136 multiplied by 10 raised to the power minus 23 watts. If you just solve it from here, right? So that's the final answer here, PR. That's the receiving power on the receiving side. So it's 8.1136 multiplied by 10 raised to the power minus 23 watts. So that's the receiving power that we were looking for, and that's all, gentlemen. In this way, we can beautifully you can beautifully calculate the received power on the receiving side. Anyhow, gentlemen, I'm already working on some Tesla towers. These are the Tesla coils here, and I'm trying to deliver pure electric power wirelessly on long distances. I'm going to make a video on these Tesla towers as well soon. So if you like this video, kindly subscribe my channel and share it with your friends. Thank you very much, gentlemen.